Okay, for people joining this live stream, we are going to be talking about natural language processing in Wolfram Language, and in particular about text normalization. And I think Etienne said he had something to show here. So let him go ahead and share his screen.
Yep. Okay, so we came up with a need of additional text normalizing function in the language.
You might want to clear your email off your screen.
That's true. That's good. What? Let me just go in another space. Up. There we go.
There.
Yeah. Sorry for the external sound. Yeah, so we already have functions that kind of do some sort of normalizing, like remove diacritics, transliterate, to lowercase, capitalize.
Transliterate is not complete. And that's been an ongoing issue, which I thought we had found. I thought somebody was trying to do the remaining languages. That was something that Alan Joyce had, I think, some student-y person who was looking at some of the languages which we cannot successfully transliterate.
Yeah, I know, Francisco, you and someone else took a pass at an initial improvement to transliterate, and I think there was still an ongoing secondary project to extend.
Well, there was this student who was going to do something on this. I don't know what ever happened to that. I mean, it requires some research about these languages, right? So, I mean, to see an example of how this fails, just do something like word translation. If you just type this in,
yeah,
word translation of, I don't know, some word that like quotes fish, comma all. I don't know why it's so slow for you. Okay, there we go. Now just say transliterate %.
Yeah. Do I have to map or?
No, well, I don't know. I don't think so. Okay, so now what you see is mostly it's worked, but like Burmese, it didn't work.
Yeah. Northern Pashto.
Right.
That's some weird characters.
Right. So there should be a romanization mapping, which I thought was in CLDR or whatever it is, but apparently it isn't, and it actually requires some research for the more obscure languages.
Right. So right now, Transliterate is using all the CLDR available stuff, and we updated that with the latest version available at some point. But of course, we will need to add our own transliteration rules for some cases.
Right. So there was this student who was supposedly going to work on that. What happened to that? Do you know?
No, I haven't heard anything.
Okay, so why don't you find out from Alan? Because if somebody just forgot to contact them, then that would be a shame. But I'm sorry.
No, it was just general comment about transliteration. It's a tricky function. Like many language, there's several possible transliteration. And,
I'm aware.
We did some tests to update the language classifier. Amir did some tests to just take some text and transliterate it, to make it more robust. So it works also on transliterated Korean, let's say. And it wasn't giving great results, unfortunately.
I see what you're saying.
He did that on Persian, like he speaks Persian, so he tried and he said, "Oh, I wouldn't transliterate it like that."
Well, so he disagrees with the CLDR transliteration, is that
yes. When he speaks with his friend using this alphabet, he wouldn't use this transliteration.
Also, we should be aware that in some cases, CLDR doesn't have the transliteration for the language, but only for the script. And we are falling back to the script, so that it's also an important difference in some cases.
Oh, I see. So maybe it was an Arabic one for Persian, because it uses Arabic alphabet.
Well, that's then probably totally wrong.
Yes, for example, we had that issue before for Russian, because CLDR didn't consider Russian and only Cyrillic, but they added also Russian, so now that improved a bit.
And how do we specify and transliterate that it is the language as opposed to just, here's a string, look at the character set?
So right now, if we have the string, we use the default transliteration into Latin, which there is one for that, but we can specify also the language itself. And in the cases where we don't have the language, we try to fall back to the script.
Okay, so in transliterate, we can specify language arrow something or other.
Yes, sure.
I mean, not now. Wait.
So it takes a source and a destination language.
Oh, I
So
see.
it's one language into the other. Yes. So it's not a language option, but
so this is actually. It has to be. Can it be string? It has to be.
It could be string, I think.
Well, that looks like a bug then.
Yeah.
And if I do Japanese, the same.
Yeah, well, so I don't understand why that's coming out red, because it's in the documentation.
I'll take a look at that. That shouldn't be going like that.
All right. Okay, but I guess that's all separated.
Yeah, that's not for your main discussion, but that's something that we should be fixing.
Topic, yeah. So this was other related function. They are not normalizing. This is just information about characters,
Yes.
but that's something we need as well. So that's the two things we're going to discuss: normalizing and information about characters.
Okay.
So these are just some standards used somewhere else from ICU. Okay. So and by the way, this came up. So it was a need, for example, when we're converting models, such I don't remember if it was BERT or GPT-2 or something like that. They were using some of this classic normalization before. So we needed this function. So two things we need. Let's start by text normalization first. Is a function that you just give text, normalize everything, and be able to put some method. So we thought of calling that. By the way, we already had some sort of brainstorm meeting with Nick and a few others, and we came up like just the name text normalize. That could potentially involve, also remove diacritics, lowercase, like this sort of things.
But what's the default text normalize? What would the default text normalize do?
Good question. I don't know. Maybe one of these four that is the most used.
Okay. So when you do NFC text normalization, the thing that will come out is humanly looks like text. Is that correct or not?
Yeah. It's text. Yeah.
And so, for example, if I had new lines, double new lines, weird paragraph markers and things, would text normalize do something to those?
I don't know the standards actually, but I assume not.
Really?
Not. But actually, I don't know. I don't know.
Also,
some of the normalization map to ASCII, for example. So after you will have an ASCII text.
No, but I understand. But I mean, here's my point. My point is that there are structured documents where the structure contains information. You get what I'm saying? And where, for example, feeding it into a neural net, the neural net is unlikely to pick up on that structure. And, the issue is, do we want to encode that structure for, in a way that can be readily picked up by a text-to-text system, for example?
I mean, then there's a text tokenization, which is another part.
Fair enough.
But I agree with that.
I think the normalization applies to sentences. Yeah, if you have paragraphs, you can first split into paragraph and then normalize as the really end.
I mean, I haven't looked, but maybe someone here, maybe Francisco, or someone knows these standards.
Yes, indeed. For example, these are part of the transliteration steps. So it first normalized to something internally, then goes to the normalization, to the transliteration tables, then normalize back. So I think some of this normalization actually ignore the, let's say, for example, change of line. That kind of characters are ignored by this normalization. But we should verify that.
Okay, so hold on a second. Let me just look at these stuff. I mean, this seems like a highly sensible function. I don't have any problem with this function. And what the one argument form should do, I don't know. Maybe we shouldn't have a one argument form initially. I'm looking at these. I don't understand item 8, fixed surrogates. By the way, in item 7, there's a question of what to do with multiple line breaks. But I guess you're just leaving those in this default.
Yeah, these were all the things that I think it was Tushita that found that. Well,
Yes.
I don't know.
So this one was found from a Python library. The Python library is called fixed text for you. So these were like other things that we could have to make it better, but these were not absolutely necessary for the model conversion. The absolute necessary was the NFC, NFKC. Like
yeah, I understand, but we're not just trying to solve the problem of converting today's model.
Okay.
So okay, what is item 8?
So
well, I mean, is that UTF-8 conversion or something, or what is that? What?
I don't remember.
Does somebody here know? Okay, so the issue is many of these neural nets are probably going to choke if there's a 16-bit emoji in the string. Is that a true statement?
Yes.
Okay, so what do we want to do when we normalize a 16-bit emoji?
So, yeah, I absolutely don't know it on top of my head.
This will be more on the tokenization part. Like no network in the net encoder. Oh, by the way, these things should be able to work in net encoders as well. But currently, net encoder has a vocabulary, and so it will just ignore if you see something that is not in this vocabulary.
You mean a character level in vocabulary?
It can be, yes.
Okay, but so again, I want to come back to what do we do with a 16-bit? I mean, what the output of text normalize is supposed to be what? ASCII text or what?
Just a string. No, not necessarily ASCII text, no.
Okay.
I think it's just a string-to-string transformation, exactly like Recombinatorics or any other things. We don't really care about the format, right? We are all Unicode. And that's why I'm not sure if these things are relevant. Okay. That doesn't change the internal structure of how it stores the text. If it's UTF-8, say 16, whatever. We have our way to encode string. That's the way it is. And we just process the strings.
Right, but the net encoder can take our encoding of the string and turn it into something suitable for the neural net.
Yes. And that's something, I think that's something separate, yes.
Okay, the large-scale problem we are trying to solve here is what?
It's just design, oh, sorry.
No, go ahead. Like the word naive, if you put, it's crazy diacritics on it. You're saying if you put those crazy diacritics, that's going to be a Unicode character that will confuse the net encoder or the actual network.
Or both. I mean, confusing, not really. I mean, you could train with the full text and a bigger vocabulary. It's just preprocessing that will help the learning afterward. Okay. So because we already know that people use, don't prove the diacritics, so
yeah, right. So okay. So this normalization, so there is a standard, hopefully, this NFC thing for what normalization does. And it seems like there are some pretty, like curly quotes, uncurling quotes. That seems like a pretty obvious one.
For example, yes.
Right. Although, I mean, that's listed there as item 5. Although it is not self-evident to me that, you lose information when you uncurl quotes. I mean, so it's not obvious that it's a good thing for the neural net to uncurl.
It's always a trade-off, yeah. If you have huge amount of data and very diverse data, which is rare, then you keep everything and it will do better. But most of the case, you have not enough data, I mean, as much as you would like, and or data that is not diverse enough. So they will all be curly quote. And then when you give a non-curly quote, you will say, I have no idea what to do.
Yeah, I understand.
Which happens all the time.
Right. Okay. So look, I understand the point of this function. Seems sensible. Obviously, we'll have to get some sensible list of what the actual targets are.
Yeah.
And I would think, I mean, the only thing I wonder about is whether there are whether that second argument represents a target or a transformation. Because, for example, you could imagine, uncurl quotes is a text normalized. I mean, that's a text normalized action, whereas lowercase is a text normalized destination. You get what I'm saying?
Yes.
Also, I think we should be able in this, if we are going to do this, for example, to lowercase to uppercase. In some cases, you need to consider the target language also, and in others, you don't. For example, the normal forms don't need to consider any language because they work at pure Unicode level. But lowercase might be different depending on the language, or uppercase also.
Yeah, that could be a language option.
Yeah, well, okay, but I'm also making the point that, are you describing the endpoint? Like the normal forms, you're describing the endpoint. Whereas uncurling quotes, you're describing the action.
Yes. So
I mean, that could say
endpoint. Yeah. So I think it should be endpoint all the time.
Okay, so then it's called uncurled quotes. So instead of remove diacritics, it would be diacritics removed.
Exactly.
Okay. And quotes uncurled poetically. And then presumably you'd be able to make a list uncurled. Presumably you'd be able to make a list, diacritics removed, quotes uncurled in a list.
To apply many of these,
to basically have something where, and some things would basically win over others.
Yeah. I mean, this is already functioned for that. So it will be just extension, because I don't think we would have a function called
no, I agree. So remove diacritics is
formalized form.
It's just, and there's a two lowercase as well. So this is just a sort of a batch way of doing text normalization, including for these named text normalization outcomes. Make sense?
Yep, I think that makes complete sense. Yeah.
Okay.
And okay, so maybe we can talk about. Okay, the second thing was about extracting features from characters. So we already know a bunch of things about some characters, like actually there's a function called character name. I don't know. This one works on? No, maybe not. This one is okay.
No, there's character data.
This character.
What is AB comma? Oh, I see. That's a list.
For now, we have a related function is character name, which is Latin capital.
What about character data? Don't we have character data?
No.
That's an internal function we have in alpha, and we have the exposed entity character, which uses this character data internally.
So
we can have
exposed character data itself.
So let's say, okay, Latin small letter A, it's a character, and it's got various properties.
Exactly. So actually, the idea would be to kind of bring this into a function, a top-level function that is fast. Because the way that it will be used, that it would process, huge amount of text to extract features. Like we would encode if it's Latin or not by an integer. We would encode, we'd encode a bunch of stuff and give that to whatever model.
Okay, hold on. What is it that you want? You want something that generates a feature vector for each character.
Exactly. Feature vector for each character.
Okay. And why exactly is that not just a net encoder of some kind or a feature extractor?
It should be a net encoder as well, yes. But you might want to use that not necessarily with networks.
Well, okay, so what about a feature extractor? But why isn't there?
The thing is, we have to be able to do a custom one. Feature extractor are usually a name, a more high-level name thing. Like we want to be able to say, I want the first element of the feature vector to tell if it's Latin or not. I want the second element to say if it's capital or not. We could have a generic feature extractor that gives all the data, but usually you don't want all the data. You want just, 4 of them.
Okay, so let me understand what you're proposing. So first of all, there are certain attributes that characters have, which that properties list seems very slim or is it not? Is that what is in the CLDR database? Those can we look? Can you just do data set of that? Just instead of properties, just say data set.
Let's see.
Okay, can we try something that's like more exotic instead of an A? Could you try to do the same thing, but let's say I don't know.
I could try this I.
Yeah, that'd be fine. Let's try. Okay. Why the hell are those language frequencies integers? I do not understand that at all. That looks like a bug. They should be fractions, right? Francisco, can you comment on that?
Yes, that's legacy data we have that we should update. Yes,
but make them fractions, please.
Sure. They mean nothing but a relative frequency, which means nothing. But fractions will be better, of course.
So can we fix that, please? I'm not sure if this is documented or not, but I think we should just fix that because that's useless. Okay, but let's take a look at this. So what other things would you like to have other than what's in here, Etienne?
Okay, I mean Latin, yes. Lowercase, uppercase, yes. If it's a letter, if it's a number, so I don't know if this is there or not. Like character 2. No.
Well, just look. You can get 2 as a character.
Yeah. Character 2.
That's weird, and that's a bug. That's a bug. You should report that thing with a 2 as a bug.
Yeah.
Okay.
So anyway, it's a number.
Wait a second. Yep. But before you do that, just say from character code 14,000. Okay. Now let's do the same thing with your. Oh, for God's frigging sake. Well, that's underwhelming. That's a bug. Let's find out what happened to it. So, like the category there should be a category property for that thing, right?
Yeah.
Can we find out what it thinks it is? Or is there a way of getting to the internal character data function, Francisco?
Not from the language right now, only with the entities. So only with the entity framework.
I see. Okay. So why do you think that didn't work? That thing with that random Chinese character? Could we just try? I mean, okay, so that's a bug anyway. That has to be tracked down. Okay. That's it.
We'll try another one.
That's a bug of some kind. But notice that it already had a bug when it tried to make the
interpreter. Yeah.
I think that character is. I think what it's doing is that character has a name, and it should be using the name. Try character name of that creature. Character name.
Oh.
Character name.
Yeah.
Okay. Now try the control equals of that thing. Oh, for God's sake. Okay. So there are a bunch of bugs around this. That's not going to help.
Oops. Okay.
Not going to help. Okay,
Alright,
so that's a bunch of bugs to do with the way that. Hold on. Let's characterize these bugs. Okay, the character name should be able to be interpreted. I think for sure the interpreter should work for that character. But then what I want to understand is your feature vectors. What is the difference between what you want to get out in the feature vector and what the entity value thing does? Do you understand the?
Yeah. I'm trying to see. I mean, one difference is that it should probably be, at least in the net encoder, it should not be lowercase letter. It should be an integer.
Okay, but that's not what we're going to put in this function, right?
No.
So maybe what we will need is a mapping or an entity type for these categories, so that you could have some kind of standard name that could be converted into the number you need, for example, or something like that.
Yeah, that's a reasonable idea. That the categories themselves become entities. That makes sense. That the possible outcomes from the categories become entities, and that then you have a mapping table that says lowercase letter is a 1, random mathematical character is a 7, etc. Is that what you think you need, Etienne?
Eventually, yes. Like for net encoder, it has to be directly integers. It cannot be.
Okay, I understand that, but I'm asking, is the only thing you're keying into the category, or are you keying into other attributes here?
No, other attributes. I mean, no, many things. I want to know like which alphabet it is. I want to know if it's lowercase or not. I want to see if it's integer. I want to see.
Okay, so
it depends on the application. It depends on the application.
Okay, so what is it that you thought you wanted coming into this meeting with character data? What is it you wanted there?
Mostly, if this is the thing that I described, like if it's Latin.
No. What's the real reason you're talking about character data? Is it because you don't think the entity property thing is fast enough, or what?
Oh no, we needed it.
No, okay, but why do you need it? Why is it any different from the entity property lookup? Why is the functionality?
Of course, I mean, this is absolutely unusable.
Okay, no. Etienne, stop. Okay. I want to understand, is the only objection that it's not fast enough, or is there an objection about functionality?
I didn't look enough in detail about its property to know if there's some additional property we need.
Okay, fine.
I think it's mostly packaging, speed, and returning performance thing. Yes.
Okay. Well,
so considering we already have the ICU library in the system, maybe we could. I think what Etienne wanted was to have a function that will access directly that information from.
Okay, which is otherwise known as character data with a second argument, right? Which is the equivalent of entity value of the character entity, comma, the second argument.
I mean, it doesn't exist in the language.
No, I understand that. We were going to have that, and for some reason we don't have that, because instead we have the entity property version. And I think it's perfectly conceivable. This is a basic enough thing. And I think that it makes sense to do something which is not a pure entity value thing, because, for example, we could do character data with a string that has multiple characters in it and have it come out with a list and all those kinds of things.
Yes, exactly. That was the idea, actually, to have many characters in. Anyway, so this was kind of an introductory meeting, and also to set up.
What's an introduction to?
I mean, I'm sure there will be more design happening. The main question we wanted answers was: should we do this or not, and who should do it?
Okay. Wait.
Sorry. Okay.
Back down to the bottom there.
Yep.
Okay. So we've got a bunch of bugs here. The idea of exposing character data, it seems like a good idea. It seems extremely straightforward for the reasons that Francisco has said, right?
Right. The only issue with exposing character data by itself would be a matter of designing if we are going to accept there the standard names or not, because if you see the standard name of characters are actually more complex. If you scroll down, please, to the ones that actually work. So if you see the full form, for example, of this Latin small letter E with the receive. So if you take the
Latin small letter I with diaresis.
Well, I noticed bizarrely, it's got a name, but it doesn't have the standard name listed in that data set, which is a little odd. But all right.
Yes, we never list the standard name there. But
okay, fine.
Right. But so the standard name is so it might be, for example, problematic to make a difference between a list of characters as a single string or a
right. So I think then character. I get the point. That's why I think character data should simply work on the character string. Do you see what I'm saying? It should not deal with the standard names. It should be able to get what it should be able to do is just like character name. Character name returns the standard name, doesn't it?
Not really. It returns a different standard. It has a different standard than the entity packlet right now. But that's something I think we should make.
That's
unique.
wrong.
Yes, sure.
Yeah. Okay, so that has to be uniformized. So character name returns the standard name. Character data does not take standard names. It could have as one of its properties standard name so that it could return that. Do you get what I'm saying?
Mm-hmm.
Although it's redundant with character name because character name will do the same thing. Does that make sense?
I wonder if we could do... No.
Okay, so character data simply takes a character string and tells you...
How many characters?
I'm sorry?
Or many characters?
No, a character string.
Okay, yeah.
Of any number of characters. And it will produce a list. I mean, this is very similar to so character data. There would be a second argument to character data which would make it behave like 2-character code. Do you see what I'm saying? Do you understand what I'm saying?
Yeah. So you mean
it would say Unicode code, for example, or comma Unicode or something as a second argument, right? And that would actually just return the Unicode values. Actually, Unicode value.
Sure.
Or actually, it could just say character code there. Now, notice that character codes in general need a character encoding.
Yeah, but when we say Unicode, we are already saying which encoding is, which is Unicode.
Well, we're not. No. Look, our own strings do not need character encodings because our own strings actually operating in the system are all, as it happens, internally encoded in Unicode, but every character in that string has a definite, is a definite character, right? It's not like we've got this bit pattern and today it means alpha and tomorrow it means, Chinese schwa or something, right? Do you get what I'm saying? But when we import character strings, we have to worry about what the encoding that was used for them was. When they are operating inside our system, we do not have to worry about character encoding. So I'm guessing character data does not have to worry about character encoding. In other words, do you get what I'm saying?
Yes, I agree. We should go to that path. So we can only have the Unicode value, and that will be enough. So if you need to do other operations, you would use the regular from character code to character code.
Okay. What else is there to discuss about this?
Well, there's some... Okay.
So, sorry. Before we continue, and what will be the default one argument for character data, or we don't?
I don't know. I'm not sure it has one.
Okay. Yes, probably it shouldn't. Yeah.
Okay, great. So if we figure out we should do it, great. And the other question is, who's going to do it?
Well, I assume that this exposure is, Francisco has already worked on this stuff, right?
Yes, character data is part of what we were planning to do after, we are doing a full revamp of language data, etc. And character data, it's actually after another project, but yes, that probably should play in my team, yes.
Great. And we're happy to give, I don't know, to discuss if needed.
But they're not doing text normalized. That's somebody different. That's you guys doing text normalized, right?
I don't know if it should be us. That's also UCI library type thing, right?
Okay, well, you have to talk to Francisco about that. I don't know who the right person to do it is.
Yes, that was between Nick and myself. to.
Okay. Well, you guys can
We
figure
will
out how
build it up.
hard this is. I mean, it doesn't look like this is very hard.
Yeah. I mean, if needed, Tushita can help or do stuff. But if it makes more sense to have to be Francisco or Nick, we would be very happy.
Okay. Well, okay. What else is there to figure out here?
Okay. I mean, this is the main thing. Then, I mean, there's always some extra things we've been discussing with Jerome lately. We can go in actually long discussions. Maybe we should not.
Oh, yeah, let's talk about this. Let's talk about this. This is important.
Okay, yeah. So we're kind of brainstorming recently. I mean, it's very early thoughts about how to extend text cases.
Thesaurusing.
To pattern matching. For example, synonyms is one of the things. Actually, this one is open. Is one of the things we could have to. All the synonyms, our synonyms are not great because there's no. I mean, we should see, but there's no. It's from word data, right? So there's no weight associated on each thing. So in some case, you have so many synonyms that are a lot of ambiguity. I mean, this is pretty clear that purchase is buy, but sometimes you have a word that is not. Should find an example.
Well, I mean, there's word sense. You should be able to have that word. Look, we have word sense entities, right? You understand? Buy has many senses. So if you say, how do we get to this? I think if you just say
data,
no, but now say, I don't know how you get
by the
purchase. I'm surprised that comes out. Nick, that's for you. I mean, I'm a little surprised that doesn't come out in terms of entities nowadays.
I think there's a plan to do that as the entity word data gets switched over, because there's two different word sources, and I haven't spoken with Alan recently about that, but I can check on the status.
Why don't you check on that? Because that seems to me that should be returning a bunch of word sense entities.
Right.
You know how to get a word sense entity?
I don't.
So
do you know what I'm talking about, Etienne?
Yeah, there's word sense.
I think I saw that once, but not very familiar with it.
Well, try entity.
Mm-hmm.
Well, no. Just try typing the entity of word sense. We don't seem to have it yet. Well, try that.
Yeah. I mean, entity lists.
You try entity list. There'll be a lot of them.
It's probably going to be long. You might want.
Oh, wow. Okay.
Yeah. Entity value of word sense, comma.
Why don't you do random entity?
Yeah.
What the hell?
Probably the display. Actually, I don't know.
Yeah, that shouldn't be taking that long.
Very strong.
Okay. Hold on. Just get 10 of them. Just say random entity, word sense, comma 10.
Okay. By the way, word sense is still under development, so it's internal only, this entity type.
Okay, fine. Okay, so what those are, but they're not properly represented there, are, they were supposed to have, and we did this in the early days of Wolfram Alpha. We had a word that described the synsets that could be given as, complement in the sense of mathematics or something, right?
Yeah, I'm not sure why they're not showing up for Etienne. They are for me.
What aspect?
The parenthetical sense associated with each word.
Well, are you running the same version?
No, I'm running 12.1, so maybe that's it.
Can you run 12 on that, Ed?
I have an old 12.1, but actually I could try this already.
No.
And
Nick, do you want to show us?
No.
But can you share your screen, Nick? Nick, are you able to share your screen? Hello, Nick. Maybe you're on mute.
Sorry. Yeah, I will.
Are you able to share your screen?
Yeah, 1 second here. So.
Oh, cool. Well, we've got a great big. What is that? That's not relevant. What are you doing?
Yeah, sorry.
Just do random entity. Well, but I just saw it on your screen. So
yeah, it must be that some of the senses don't include it. If we do sample entities, well, what the heck?
but I was just seeing this on your screen.
Yeah, let me scroll back up to where it was. Yeah, there's supposed to be these parenthetical.
Well, that's really cool. Okay, so something's wrong with that, but we don't know what's exactly wrong with that.
Yeah.
But you get what that picture. So that's highly relevant for Jerome and Etienne.
Yes. And
quite beautiful, by the way, in my opinion.
Mm-hmm. So how would you? Okay, so you do like control equal, and then disambiguate. How would you input such word sense?
I mean, I think once they're exposed, you could say something like still, and you may get word as a default, but you should also have word sense as a disambiguation option. And it's just because it's in development still, it's not exposed.
Mm-hmm.
And we also could imagine linguistics still in the sense of blah, blah, blah.
Yeah.
And I think what we could expect is we could have a version of some kind of text parsing thing that breaks instead of text words, right? We would get text words where what comes out is word entities. Am I making sense?
Mm-hmm.
I mean, it could even be called, text entities or something. I'm not sure that's right. That's not right. But that's what we want, is we want something which comes out as these tagged, in a certain sense. Now, this is a very inexact science. It isn't really a science at all, because word senses are a mess. And, I don't think we can guarantee any stability of word senses, not least because language evolves and so on.
Yeah. So we thought of
and by the way, those sentence frames need to be in a much more computable form. You see those sentence frames? Jerome, you see those sentence frames? Hello, Jerome. Jerome, are you on mute?
Yeah, sorry, I had the problem to unmute. Yeah, exactly. So I see them, and that's a problem we have that to specify such a word in context. Like we don't really have a design to.
Well, we just were talking about this. You look.
Yeah, but in a programmatic way, I don't see how to.
So yeah, we had an alternative way to specify this sense that I can show if you want, like a more statistical type, or by example.
Go ahead. Go ahead.
So we're thinking on which one was it? Not synonym. Yeah, contextualized text pattern. Something like you would say a word.
We talked about this once before.
More than a word.
Yeah, I understand.
And then,
yep, we talked about this once before. I mean, we talked about the idea, I think, of text element. What was the story with text element and contextualization? We already had this discussion.
I don't remember.
I think I have notes about this. But the question here, the problem is, what if there's two apples in that second sentence? I'm sorry?
Yeah.
Exactly. That's the problem. Like we don't have a programmatic way to.
It's a bit. I mean, the alternative.
So what we need is a textual notion of a lambda. In other words, what we need is something, right?
It's like, it's a bit. Honestly, I think this one should still work because 99% of the time you have only one apple.
I understand. So this is exactly the same thing, right? If you think about this like a lambda, okay, what's happening is that is recognizing, that's. Yeah, I mean, but I don't even think that's the right way to do it. I think there's probably some notation that we want in the string, like we need for those sentence frames, right? But the sentence frame has a pattern object inside the string.
True.
Now, I mean, we could do that using string expression.
So it did something like this, right?
Yeah.
Or actually, it's inside the string, right? It's like some special character.
I don't know. I mean, so one possibility. Okay, so that raises the possibility. Okay, here's an example of possibility. Right now, we have string expression, right, which is an extra stringular, so to speak, version of making patterns. Okay, what I'm potentially thinking is there might be an intra-string version of that using special characters.
Mm-hmm.
Do you get what I'm saying?
Yeah.
And that could be equivalent to a string expression, maybe. Although naming them with an external, it's tough to see how you would get the naming. The pure version of that without a name, I think, could be intra-string, right? By the time you've got an X there, you've got to have that X agree with the X that's in the outside world. Am I making sense?
But if we are going to use named patterns, maybe we should use some kind of conditional, like a slash, semicolon, and something to compare.
No, but I'm saying there are cases in which you want an unnamed pattern or possibly an unnamed lambda-like thing, right? A hash-like thing inside the string, right? And I'm saying we could imagine doing that with special characters. By the time you need to name it and use it externally, I don't think that will work.
And what about the string templates? It uses sticks.
It does, yes, it does. So that's a good thing to think about there. Yeah, that's a good idea. That string template is another pattern for this. That's a good idea. That's already something where we have the notion of naming. Yeah, it's not totally stupid at all.
So, and string templates support unnamed and named.
Yes,
slots.
That's right. That's correct. Although then naming is a string name. All right, so let's just get a sense of what the bigger picture is here. So first thing is we need some function that is going to try to turn a sentence into word sense entities, right? That's one thing that's clearly useful if we can do that. Do you agree?
Yes.
Yep.
Okay. So this idea, what really is this contextualized pattern? Is it in fact something that is trying to represent a word sense entity, or is it something that's floppier than that?
It could be both. So I was thinking of one that would try to match the exact string and try to have the context vector, because in implementation, we transform all of this. We transform this one into a vector representation of this word in this context, right?
Yeah.
So we try to have the distance in this vector space, smaller than a threshold and exact match. But you could also have one that doesn't look for the string match at all and only operate in the feature space. And that would grab synonyms, that would grab related concepts. It's a bit more fuzzy. And of course, there should be a way. In both cases, there should be a way to have a threshold argument or threshold option to see how far we are the scope of the pattern.
Well, this thing, by the way, basically there's a text pattern concept that we can imagine that can deal with contextualization and a bunch of other things. Yeah, for example, a text pattern could deal with you seem to have that. Open it up. Okay.
This would be when you have many of them, like defining a concept. For example, this would be defining the concept of cities, or maybe European cities in that case. It's pretty
well.
Whatever.
Hold on, that's a different thing again. In image cases, we've got this idea of, and I've now forgotten what final syntax we use for that. If you show it, 10 examples of a cat, then it should be able to. How does that work for image cases? Can you remind me?
That should be it. Yeah, you should be able to. Not right now, but the idea is to have this semantic pattern or something like this, image semantic pattern, or image pattern object, and you give many pictures of cats to understand what a cat is, and find cats in whatever new picture you give.
Right. But so with words, what you're doing here is, in one sense, you're trying to create a concept by combining a bunch of words here.
Yeah.
And the other thing you're trying to do is to drill down on a particular word to look only at certain senses of that word, which are two different kinds of
Yes, it's two different kind of things. And also this one is really about contextualizing, like disambiguating, while this one, I mean, you could also disambiguate.
No, I'm saying one of them is drilling down and the other one is puffing up. Right. So the first one, what you're calling contextualized pattern, is drilling down. The word was, was set, for example, but there are 15 meanings of set, and this is drilling down to a specific meaning. Whereas in the second case, what you're doing is you're saying, I want to make a super word, which is my whole category there.
True. This one is a bit in the middle, though. This one, with the woodroot and carrots as well, would say just start from this word. I guess it's the one.
No, but my claim is this. Okay, words are a certain. Okay, consider meaning space, right, and consider regions in meaning space, right. Yeah. Words represent a particular region in meaning space. Okay, there can be more specific regions in meaning space. So a word. What is a word? A word is something that, is, you can think about it as a function, as a distribution with support in different parts of meaning space, if I'm making sense, right? And so a word sense might be a thing with smaller support in meaning space that's just a subset of the region with support for the word. A super word would be something that combines a bunch of kind of these regions in meaning space. Does that make sense? So I claim that the underlying concept is essentially, I mean, it's similar to learned distribution. It's essentially some distribution in meaning space.
Yes.
The underlying thing,
yes.
Right?
Yes,
so it's some kind of concept distribution. Okay, so now you're poking at that concept distribution in various different ways. So, for example, one concept distribution would be, there are various named concept distributions. One named concept distribution is the word set, for example, right?
Yeah.
Another named concept distribution is set in the sense of a tennis set.
Yeah.
Right? Another named, another thing which doesn't have a name. So the synonym sets and so on don't really have names. In some cases, okay, in fact, English doesn't make a good distinction between the set of fruits and fruits, right? So in other words, it might be a different thing to say, it's not self-evident that fruits means apples, bananas, pears, whatever. In other words, what am I saying? There is a category of fruits, and then there are individual fruits which are members of that category. Does this make sense? And those in general are okay. So I mean, I think what we need here is I don't yet understand completely what this is, but it's some kind of
there's a hierarchy.
Yeah, but I think the concept is going to be a text pattern. That's my guess. That's the general. I'm not sure. Yeah, Carl on our live stream is commenting that chatbot building systems, and this is something we've done since forever. They let you give some phrases, and then the system can generalize to other phrases. And that's exactly what, I mean, we've tried to build a bunch of automated systems for doing this since the early days of Wolfram Alpha. And I'm not sure that is similar to the famous Mr. Smith, Mrs. Jones problem.
Yeah. Actually, on that topic, it doesn't have to be a word. This could be a phrase.
Sure.
Or a sentence.
Yeah, it could be. Right, but I mean, so the concept is a distribution in meaning space. And how we get to that distribution in meaning space, there are a variety of ways to do it, from named things to neural net things to whatever. Now, once we have one of those things, there's a question of, well, what is the question? The question is, given one of those distributions in meaning space, does that appear with sufficient, overlap, integral or something, with some particular thing in our piece of text? If that makes sense. See what I'm saying? So given a distribution in meaning space, the question is there anywhere in my text that has reasonable overlap with this distribution in meaning space? And that could mean that the thing that appears in my text covers, it's okay. Every word in the text, let's say, or every phrase in the text is another distribution in meaning space. Am I making sense? So now the question is,
well, for given text, it would be a precise point in the space.
I don't think that's true. I don't think you can determine that from a text. I think it's one of these.
Technically, that's how we would do. We would put a.
Well, I understand you can get a feature vector, but conceptually, but you can imagine an ensemble of possible feature vectors, all kinds of different ways to implement it. But the truth is that just saying one sentence doesn't home in on a specific point in meaning space. It might, but it probably doesn't. I mean, the number 2, right, probably has homed in on a specific point in meaning space. But, for example...
you could have ambiguity even with the context as well.
That's what I'm saying, yes. I'm saying, I don't know, the dinosaur will live another day. I don't know why I'm picking that sentence, but I'm sure we can pick that apart. That sentence has all kinds of shades of meaning, and it is not on its, that sentence on its own.
Mm-hmm.
If that was in a whole story about how, all kinds of different things that could mean, that depend on the ambient sort of understanding that. So my claim is that as you go through a text, that you can think of every piece of that text as representing some distribution in meaning space. You can also think that you are searching with text cases for something that quotes matches some distribution in meaning space.
Yeah.
Okay. But the notion of what it means to match may be complicated. For example, it could be that the thing that appears within the text is contained entirely within the distribution in meaning space that you are trying to match to. The distribution could be generally describing fruits, and apple and banana could both just be, sub-distributions inside there that would just straight match. Or alternatively, it could be that the thing you're asking for is purchase, and what's in the text is buy. And those have an overlap in meaning space. Does that make sense?
Oh, definitely. Now, to make it practical to use for users, I guess should be something quite simple. I completely agree conceptually. Like defining, like something simple would be to defining a centroid for whatever concept we have, and then distance, and then you can specify a threshold.
I don't know if that will work. The issue is you are thinking in terms of this kind of crazy linear vector space idea for representing meaning, which I think is ultimately corrupt.
Not linear necessarily. It could be. It could not necessarily be a centroid. It's true. It could be many.
It could be many things. It could be a very strange shaped creature. I think that that's the problem with synsets in WordNet and so on. That this question of how far out you go. If you try and use our synonym system to actually do something semantic, it will not work very well. and no synonym system does, because these, where you get to by jumping from word to word in a synonym network, you get a long way, because these things aren't, what am I trying to say? I'm not a great believer. I can imagine, okay, it's like in color space. You go a distance 0.1 in color space, it means a different thing depending on where you are in color space. In word space, in meaning space, I have to believe that going 0.1 in meaning space is a crazy concept. Okay? In other words, that some parts of meaning space, like for instance, okay, let's imagine you're doing medical stuff, okay? Distance 0.1 in meaning space between a liver and a kidney might be quite small, right? Those two might be the same. They might be within 0.1 in meaning space, right? But it certainly matters, which one of those some diagnosis is about. Yet 0.1, distance 0.1 in meaning space, when you're talking about, am I making any sense here? I mean, my point is, I don't think there's any meaningful sense in which you can have a uniform meaning for 0.1 in meaning space, independent of where you are in meaning space.
You mean like some regions of the space are more dilated than others?
Yeah, and it depends on what you care about. Because if it's a I mean, I hate to say it, but if you're going to eat the animal, right? You probably don't care whether it's this muscle or that muscle, but you certainly do care if you're trying to, make the animal be a better racehorse or something. So I think it's really, I'm skeptical. I mean, there's a
you can figure out kind of the distance from the examples. Like if I have something very specific,
fine,
very close to each other, you say, I mean, it's
right, but then you can't
exactly as you say. Is all of these points in the space? We can learn the distribution given this. I mean, of course, it's only 3, 4 is going to be a bit hard, so it's going to be very simple models.
Right, but I mean, you can do in your learn distribution system, you should be able to learn a distribution from those points.
Yes.
Right, and that distribution in meaning space, it'd be interesting to see what it is. Who knows where that goes? I mean, for all I know, there's a type of cocktail that has all three of those. It can get very, very weird.
No, I agree.
But so to make this meaningful, I mean, okay. So look, I think this is a super interesting conversation that we and I think we can do something really good here. I think it needs to be a similar kind of approach to what we're doing with image cases.
Yep.
But I think that the way to think about this in terms of I mean, I think we've got these various named things like a word or word sense. That's useful. We've also got these category names, which we use in things like image identify, and which in our new kind of entity ontology, we're likely to pay more attention to. Does that make sense? So a category name is another, in fact, this is a good point. Okay, so a concept or category is another entity. In other words, the concept of fruits is not the same thing as the word fruits. And we distinguish that in our system.
Mm-hmm.
And that's a good thing, because the concept fruits is a whole bag of, I mean, we're already doing some of that in text cases right now. Okay, so this is another comment. So in text cases right now, we are able to pick out entity types. We're not able to pick out entity classes, right? So for example, I don't think we could ask for fruits right now, but there's no reason syntactically, we've got a way to ask for that because we have a concept of fruits. Does that make sense, Jerome?
Jerome is mute again. But yes, it makes sense.
And that seems to be something that I could imagine us being able to do fairly. Jerome, are you back yet? Oh, for goodness sake.
Having technical issues. Okay, it's a bit late for. Oops.
The
Where am I? Where was I? No.
Well, we need to wrap this meeting up actually, but
Yeah.
but
Just to give you, I think technical problem of Jerome, definitely. Other things was like, introducing things like fixed order, like this sort of things.
yeah, all the stuff that's in grammar rules.
Exactly. I think we should do it. And we quickly discussed about, things like,
Yes, that's
I want to
important.
match, but I don't care. I'm insensitive to the case. I'm insensitive to the critiques, this sort of stuff. And maybe some way to do some tests, like condition or.
Yes, that would be good too.
So anyway, that's
right. There's a quite different thing, which is lemmatization and inflections and so on. And there's a separate project which was supposed to happen, which was curating inflections of words.
True. This one have issue though that they're also in context to be correct.
Of course
like
they are.
Meeting,
yes, of course.
We don't know if it's a noun or a verb. So I don't know if just part of speech is enough to disambiguate. Probably not.
No, it's not. It's not. It's not. Simply not. I mean, this is the same thing. Yes, we will need words in context. Again. All right, we should look at the live stream here, and then we should try and wrap this meeting. Actually, we have another live stream meeting coming right up after this. Okay, Seth is asking about NLP glove nets, and the repository don't include networks used for training. I suspect that's for licensing reasons, but I don't know. Maybe Toshita knows.
It's true. We should set up training networks as well.
Okay, we are in a position to do that?
It's, I think so. We can create us ourselves. I don't think we had access to but we can create the training net. Because it's not the first person that asked for how do I train my own word vectors.
Right.
So that would be good. It should be not too hard to set up.
Okay, that's a two-seater issue, I think.
Yeah, with Jérôme or Timothée to help.
Carl is talking about Wikidata having a lexemes thing. I don't know anything about that. I mean, I know what a lexeme is, I think. Yes, the whole business about being able to do offline processing with grammar rules, that is coming. Slightly slowly, but it is coming. We are not far away from being able to have a standalone version of that. Carl is saying, love better usage flow for neural networks as feature extractors and classify. I thought that was pretty good. Doesn't classify have? Could you just show that for a second, Etienne?
Yeah, show what?
Well, how you use feature extractors and classify. I thought it was just an option to classify.
Yes, classify, then it's feature extractor, and it can be a named one, or it can be a function as well.
That looks pretty clean to me. I think Carl needs to try the latest version.
You can also create feature extraction before, and then include it to classify. That's important, by the way, in practice.
Yes.
So either at training or afterward. That's also interesting. Like you can say, then I extract features of the data, then I classify with these features, and then you say, oh, actually, I needed to prepend. That you can do it with classifier function, I believe. Feature extractor, and then you put the previous feature extractor, and you just.
It's not a good sign that just turned red.
That's true. That's true. Is it in classify or is it classify again? Oh, interesting. Yes, you can do feature extractor. We forgot to add it to the table. That's why it's red.
Okay,
well, that's a bug.
That's a bug.
Nope.
Okay, well, let's wrap this up. This is interesting stuff. We should continue in not too long and talk about when we continue. We probably need.
Actually, it's classify. Sorry, it was that. It was not a bug. It was classify. It was not feature extractor.
Okay.
You redo classify, whatever. Okay.
On the classifier function.
Yes. Yes. It's a classifier function. like it's there.
Okay, next iteration of this, do we have anybody project managing here?
I'm here.
Oh, okay. You've been very quiet. Okay.
I was taking down all the bugs though.
Good. Okay. I think we're going to need Alan in a future discussion of this, because I would like to make sure that this dovetails with all the stuff we're doing on curation of words and word sensors and so on.
Okay.
I would also like to know what happened to the inflections project. Francisco, do you know anything about that? Was that ended up in your team or not?
No, the inflections project. No. Well, I was looking at a bit of that for localization, actually, but that's a different project.
Right. Okay. So I think that's with Alan. So he would have to be part of this thing. Okay. Terrific. Thanks. Thanks to local folk. Thanks for the comments on the live stream. And if you're into live streaming, we will be in about 5 minutes. We will be doing another one. All right. See you all soon.